For our Math 1001 class in our summer section, we didn't get a chance to talk about section 3.2, compound statements and connectives. Let's do that at this time. So if you want to follow along in your book, you can. This part is simply going to be note-taking and explaining. So 3.2, compound statements and, let me write that over here, connectives. So here's my question. If you know how to do this, then you know this section. How would you translate the following sentence into symbolic logic? You will pass if and only if you study, and if your absences are less than 4, then your grades count. Now that sentence may not seem sensible, but it's a good example of how I want you to be able to put a sentence together. So that was, if I pass, if and only if, that's a biconditional. And then I have a series of things that you study, and there's if your absences are less than 4, so if your absences are less than 4, then your grades count. Now, in a biconditional, that has the most dominant theme, so this whole thing has to go together. And this is an and this is a conditional, so these would have to go together. You will pass if and only if you study, and if your absences are less than 4, then your grades count. Now that would be a way to translate that English sentence into a logical statement using symbolic logic. Okay. So let's assume that you weren't too sure how to do that. You will at the end of this lesson. The first thing that we need to do is we need to understand the idea of simple statements. Now we've already talked about that. Then we need to know, we need to talk about the idea of compound statements. Now then we're going to talk about connectives. Now, what are connectives? Kind of like toys. You have, toys and these little things that connect them together. Connectives are logical phrases that relate statements to each other. Here's some connectives. And, or, if, then, if and only if. Okay, so remember, we're just talking about the simple, basic things about logic. And if we can understand the simple things, our understanding will be able to help us. So let's take it a step at a time. Let's start with A. We're going to talk about and statements. Okay. I wake up and I have breakfast. We're going to use the letters P and Q. P and Q. I could write it this way. P, see that symbol? Q. You can call that symbol hat. You can call that symbol house. You can call that symbol carrot. Now here's an example. I study for the class and I attend. Okay, that makes sense. Another way to say a P and Q is to say P but Q. I study but I attend class. I could say P yet Q. I study yet I attend class. I could say P nevertheless. I study, nevertheless I attend class. So all of those statements are statements in the field of logic. Of course, we're not talking about everyday speech that someone may say at a restaurant, but we're talking about us examining this field a little closer and getting an understanding of how the words relate in this particular area of knowledge. Logic is very important. So all of these mean the same thing. P and Q, symbol. I study and I attend. P but Q, P yet Q, P nevertheless Q. Okay? I will get an A in this class, nevertheless I had to study. That would be a good example. So those are and statements. Let's talk about B, or statements. Okay, so I could say P or Q. Now here's the symbol, P. Okay, it looks like a V, looks like a inside of a boat, looks like a valley. Some examples. I visit London or Paris. Now, what if I wanted to say I'm going to visit them, but I'm not going to visit the both of them? I would say I visit London or Paris, but not both. Okay? Or maybe if you want to, you could just say, I visit London or Paris, comma, not both. Now there are two types of or in our study. And we talked about this, but I want to give it to you a little bit better here. There's the exclusive or, and then there's the inclusive. Okay? All right, so perhaps you know a group of girls, okay, guys, and you go, you could date Sally or you could date Sandy, okay? And then, one week you date Sally, another day, another week you date Sandy, okay? Now, someone's going to get upset if you date both of them, but let's say you do date both of them, okay? That would be inclusive. All right, but I know you're the upstanding individual you want to be, and you want to give your full attention to those individuals, so you're going to date Sally, and then if you go out on another date, you take Sandy, okay, but not both. So that would be exclusive. So an exclusive or is like salad or soup. Okay, they're not going to give you both, people. Inclusive would be water or coffee. Okay, all right, so we're familiar. You can get coffee and you could ask for water and you can have both. Now we're going to assume that all of the or statements that we are going to use in our unit of study on logic are inclusive. You can have both. You can have both. All right? If we need to adjust that, we'll adjust that at a further time. All right, so that's the or. We talked about the and. This is the or. Now let's try to apply this. Okay. I think you got this, so let me erase this. We're going to say P means you graduate. I hope this writing is big enough. Q means you pass math requirements. I'm going to abbreviate. You pass math requirements. All right, so now I want to know, how would I write this? Q. How would I write that in the English? Well, I have Q, which means you pass math requirements. Okay, I got the symbol which means or what? Now it's not P. So P is you graduate, and guess what? Or you do not graduate. Okay. I'm a little sad here. Okay. What would P or Q? What would this? How would you write that? Well, you would simply say you graduate or you pass the math requirement. Okay. All right. Now in this case, you could do both. Remember, I said it's a inclusive or. So keep that in mind. All right. So that's what we put a couple things together, and we tried to marry it, if you would, with some language. All right. Let's get rid of this. Now I want to talk about C. If-then statements. Okay. Now you have had a lot of this in high school geometry. I don't know if you had a lot in your other courses, maybe a science course. If-then statement. Okay. If a figure has 4 sides, then it is called a polygon. If a figure has 4 sides, it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. Now, how about this statement? If you are a freshman, okay, if you are a freshman, how about we do that, okay? In this class, okay, got if, then you are a UWG student. Okay? So if you're a freshman in this class, then you're a UWG student. I got an idea. What if we used some circles? And I called this one U for UWG. So let me cheat a little bit. UWG. Okay? Now, here's the circle freshman. Okay? According to the sentence, where does that circle belong? Outside, some of it, or all in here? If you are a freshman in this class, then you are a UWG student. Okay? So, we may not have used the word all, but that's a conditional. So I look at someone in the class, and Joey is a freshman in this class. What can we conclude? That he is a UWG student. Now notice we're using some of the ideas from set theory to make this clear and to convey these ideas. Now this is a conditional statement. If P, then Q. All right, so if P, then Q. Or I could say, if F, freshman, then UWG student. Okay? That makes sense? Now, I could write it in a shortcut way. All right, this means if P, then Q. All right, so this is called a conditional statement. Conditional statement. All right, one very important thing about this notation is the first part is called something and the second part is called something. All right, the first part is called the antecedent. Antecedent. Okay, like AM, you know, here's the sun in the middle of the sky, okay, noontime. Everything before here is called AM, okay, because it's anti or before the meridian, and here's PM, post meridian, after the meridian. Okay, that's just free, okay. Now, the right side is called the consequent. Consequent. So the first part, the if part, is the antecedent, and the right part, or the end part, is the consequent. Now look at this some more. I'm going to define P as a person. A person is a father. Okay? I'm going to look at Q as a person. A person is a male. Okay? Now, I want to know what this means. Okay, that means if a person is a father, then that person is a male. I want to know what this means. Hello? Hey, this is Bob. I'm up at the church building making a lesson for my class. I will call you when I'm done. Okay, sorry about that. I noticed that I didn't hit pause, but I apologize. All right, here we go. All right, how would I say this? This would be Q, then P. So if a person is a male, then the person is a father. Okay? How would I say this? That's a good question. Now notice in this case we have a Q and a P, but we have not and not, the negation. So it is a conditional. So I'm going to say if a person is not a male, then the person is not a father. Okay? It's very important for us to be able to get the basics down before we go further. So we're going to call that conditionals and the English language. Now, let's come up with our own example. Okay? You know, instead of the freshmen in the class here, how about if I study hard, then I will get an A. Okay? Now, don't hold me to that, okay? But if I study hard, then I will get an A. All right? So let's just call this part P, and let's call this part Q. All right, what are some different ways that I could write it? Well, obviously, if P, then Q, got that. I could write that out, if P, then Q. Okay, we get that. I could also say Q, if P. That's another way to say the same thing. I could say P is sufficient. P is sufficient for Q. Okay? I could say, also I could say Q is necessary for P. I could also say P only if Q, and then I could also say only if Q, comma, P. Now, I know that that sounds like a mouthful, but it is important in your schooling and in your reading, you will come across these words from time to time. All of these 6 items mean the basic conditional if P, then Q. So let's say them. If P, then Q. Q if P. P is sufficient for Q. Q is necessary for P. P only if Q. Only if Q, P. Now again, all of those statements mean this. So if I see a statement in that form, I need to be able to translate it from one form to the other. Okay, so let's use our example. Study hard, I will get an A. All right? So this would be, if I study hard, then I get an A. This would be, I get an A if I study hard. Now that does make sense. All right, this would be, I study hard is sufficient for a Q. All right, I know you're wondering about that one. Okay, Q is necessary for P. I will get an A is necessary for P. Okay, that is a way to say it. Let's go to this next one. P. Okay, I study hard only if I get an A. Now, this only if really means this. Okay? You may be thinking this, but only if is the same thing as the symbol or the word implies. Okay, so let's say that again. Studying hard implies I get an A. Okay, so if I study hard, only if I get an A. I know it doesn't register, but we're going to have to go with it in that example. And then here's one right here. Only if Q, P. So only if I get an A, I study hard. Just keep those in mind as we work on through our material. Now, I want to talk about something that puts some things together. And we call it, well, yeah, okay. Let's call it D. And we're going to call it if and only if statements. Now, I know you saw this in your math book, and you probably saw it in some science books. If and only if statements. All right, so let me ask you a question. I know, you don't watch this show, okay? The Bachelor, okay? Or maybe you do. All right, now what is a bachelor? A bachelor is an unmarried man. Okay? That's what a bachelor is, an unmarried man. All right, now let me ask you a question. Okay? Here's a student in the class. He's a male. He's unmarried. Can I call that person a bachelor? Yes. So what are you saying? If I have a bachelor, then I know that I have an unmarried man. If I have an unmarried man, then I know I have a bachelor. So it's like a definition. Definitions, if you would, they work both ways. So let's see if I could write it another way. If I have a bachelor, then I have an unmarried man. P, Q. All right, so that means if I have a bachelor, I have an unmarried man. It also means if I have an unmarried man, then I have a bachelor. Okay? Now, when we think about that, that is called an if and only if. If and only if. You see that? This one's if Q, then P. This one's P, only if Q. And notice there's an and there, which means both of these are true together. So this way of arranging a definition, the bachelor and the unmarried man, is called a biconditional. Okay? All definitions are biconditional statements. Biconditional meaning there are two, you can make two conditions out of them. Also, there's a symbol for this, and the symbol is this. Okay, now I know you've seen this symbol in some of your math textbooks. That's where it came from, in case you didn't know. Also, there's a new symbol. So instead of using the symbol going this way, we're going to use this symbol. Okay, it's kind of like you know, the person went that way. Okay, so this symbol with the two arrows represents the biconditional statement. Keep that in mind. In your book, there's an example, and the example is a definition in an English dictionary, and it's a definition of the word word. No, that's not it. It's the definition of the word set. Set. And if you look at the definition of the word set, there are 464 meanings. Okay? That is a lot of meanings for the word set. So, let's see, how could I say this? Let's say P is the word set and Q is 464 meanings. Could I say this? P only if Q, if and only if Q. Could I say this? That would be not Q if and only if not P. But how would we say this in words? All right, now that's a good question. So we need to be able to go back and forth with our sentences, with the words, and keeping our grammar pretty consistent all the way through there. So I would say, remember Q is, the word has 464 meanings, and P is the word set. So I would say this, the word does not have 464 meanings if and only if the word is not set. You may have to rewind that and listen to that a couple times, but that is the way you do that. Okay. So we talked about if-then statements. We got the gist of it here. Then we talked about if and only if statements, which we understand is called a biconditional. Now, just like there are several meanings to pulling or identifying a biconditional in an English sentence, the same thing with the if and only if. So, to mean that, a biconditional, okay, we could use this. P, if and only if Q, we get that. I could say Q if and only if P. Whoops, forgot to put the word if there. Q if and only if P. I could say if P then Q, and if Q then P. I could say, remember those two words we had before? necessary, and then we had the word sufficient. So I could say P is necessary and sufficient for Q. Okay? I could also say it this way. Q is necessary and sufficient for P. Okay, I think you get that. All right, let's look at an example. Okay? How about football and UWG? Okay? So if the football team wins every game, then we'll have an excited campus. So how about we change this to wins and this to E. I want to know what this means. Think about that. What does that symbolic, logical statement means? Well, it means if the football team wins, then we'll have an excited campus. And it's also saying, and if we have an excited campus, then the football team wins. So either way, let's hope that the football team wins, and let's also do our part to have an excited campus, because we like an excited, learning environment. All right, let's summarize for a second. We have been talking about logic. We talked about simple statements. What is a statement? It's a sentence that is either true or false, not both. We talked about negating simple statements, putting a not before it, or it is not true. We talked about the conjunction. The conjunction was, here, let's just put this over here like a little review, okay? All right, the conjunction was the and. Hey, that looks like the A in and. Then we talked about the or, okay? That is called the disjunction. Conjunction, disjunction. Okay? And then we talked about this, which is the conditional, and we just got done talking about that symbol, which is a biconditional. Bi, two, like bicycle, two wheels, biconditional. All right. Let's move on. So let's erase this. Now, training, I want to say this while I'm erasing this. Training the mind is very important. It's not telling you how to think. It's not telling you what to think. It's helping you to think. I do think in our society that there's a matter of having sway over the minds or the loyalty of groups or subgroups in our culture. And I have found out that the use of logic or bad logic or the use of fallacies and taking advantage of people's poor reasoning ability is something that if we're aware of and we could be on the look for that and have some type of training, it will really help us as a citizen of our country. So that's something to think about. Okay. Let's look at part E. We're going to talk about symbolic statements with parentheses. Sorry about the spelling. Okay, now, we have seen this before. Okay. So if I said I have three sets A, B, and C, you know this is an intersection. You know that's a union, and you know you got to work with that first. Well, I could use parentheses in logic. Okay, how would I say that? Would I say that not P and Q? No, because the P and the Q are together. So I would say it is not true that P and Q are true, or it's not true P and Q. Of course, there's different ways to say that. Now, how would I say this? Not P and Q. Not P and Q. So think about how you say it. Listen carefully. And again, that's something that's going to help us out. It'll be a good situation. Let's do an example. All right, let's say P is he is employed. We all like that. We all want to be employed. All right, Q is he is happy. All right. Now, I want to know how we can say this. I want to know how we could say this. I want to know how we could say this. All right. So, what is this? All right. It's not true that he is employed and he is happy. Or not, he is employed and he is happy. This is, he is not employed and he is happy. Okay, now what's different here? Here we have the disjunction. So we would say it's not true he is employed or he is happy. Now there's significant meaning to how we would use that in an argument and how we would understand the truth values. But right now it's just important for us to know if we're talking about both of them, if we're talking about neither of them, how we're putting it together in words. All right. All right, hold on a second. Hello? I'm at the church building working on a lesson. It's a lesson for my class. I'm almost through. I'll tell you when I get home. Bye. Okay. All right, now. Let's talk about compound statements with more than one connective. So we just talked about parentheses. Now, compound statements, we could call this F, I guess. You may remember back to the beginning of this lesson, I had a statement that had a lot of parts to it. All right, here's an example. Now, how would I write that in words? That is a very good question. Okay? Notice it's a conditional. Notice I have three statements, and notice that these are grouped together with an and. If Q and not P, see the comma? If Q and not P, then not R. Okay? Now try not to worry about what each of them mean, and am I going to, lose an argument? You're just trying to get the basics and the form together at this point. Let's try that again. Q and parentheses, not P, arrow, not are. Wow, that is a mouthful right there. Okay. All right, I should be able to graduate just being able to say that. All right, let's see. How would I say that? First of all, the major form is the disjunction. So I'm going to start Q. Okay. Now, is that an and or an or? Okay. That is an or. So Q, I'm going to put a comma there to indicate to the writer that that's on one side, and I'm going to say or if not P, then not R. Okay? Now you may have understood that correctly without that comma there, but because I put that comma there, that helped me to indicate Q is by itself, like over here. This is not or. Why did I say or? This is and. And. Okay? Q and if not P, then not R. You got to work at it a little bit, and with a little bit of practice, you'll be okay. Okay, so what if we attached some meaning to P, Q, and R? Now, that's a good question. So P, a student misses a lecture. I'm going to say misses lecture. Q, I'm going to say a student studies. And I'm going to say R, a student fails. Okay. Now, how would we say the top one? I would say if a student studies and does not miss a lecture, then the student what? Does not fail. Okay, that makes sense. Okay. Now, how about this one? Let's start with Q. A student studies and if the student does not miss a lecture, then the student will not fail. Okay, that first one probably made a little more sense to you than the others. They do not mean the same thing. Now let's erase this. Now when we're looking at a statement, and this could be in a textbook, it could be reading the IRS tax code, it could be reading your IRS instructional booklet, which I always, I really encourage you to do so with a cup of coffee so that you don't fall asleep. We want to talk about something known as dominance of connectives. Okay. This is important, and it's easy to remember. Sometimes you don't have the parentheses in the problem or with the symbols, and sometimes you don't have the connectives there as well. There's no commas, no parentheses. So what we're going to do is I'm going to give you a diagram. Okay, so I'm going to call the ones on this side the least important and the ones on this side the most important or most dominating. Okay, we've got 4. So let's cross it here, here, and here. All right, as you can imagine, the least would be the not. Then the and the disjunction are that same level. Then we would have the conditional. And what do you think is the most dominant? That would be the biconditional. Statements before and after the most dominant connective should be grouped. Statements before and after the most dominant connective should be grouped. All right. So we've been through a lot. We took it a step at a time. I tried to, boil it down. And I began the study with this statement. You will pass if and only if you study, and if your absences are less than 4, then your grade will count. All right, I heard pass. I heard if and only if. I heard study. I heard and. I heard another if. Absences, then something will count. Now, according to the dominance of connectives, this is the most dominant, which means that there must be this part grouped together. But look within the bracket, okay, which one of these is most dominant? Is it S and A implies C, or is it S and then this other part, A implies C? Well, notice its priority, okay? So I would put parentheses here. That is how you would do a problem using logic and these simple statements. Now you may be saying to yourself, well, this sounds so like made up. And in a sense it is, but if we will study the form, when we go to things that are more complicated, and it may be something you read last month, and maybe something you heard on the news 2 days ago, you can make sense out of these things, and you can understand what was supposed to be communicated versus perhaps what was communicated or what the audience heard and not exactly what was said. So this is important when we're studying logic and we're trying to figure out how to reason correctly. So that was 3-2. I'd urge you to do the assignment shortly after you listen to the lecture and try to get the 2-1 to 3-2 assignments done before you come to class on Tuesday. Thank you.